What's going on, guys? Let's look at this problem right here. Here's question is asking, in the circuit of figure 7.53, W over L1 is equal to 5 over 0.18, W over L2 is equal to 10 over 0.18, lambda 1 is equal to 0.1 voltage power minus 1, and lambda 2 is equal to 0.15 voltage power minus 1. A part is asking, determine VB such that ID1 is equal to absolute value of ID2, that's equal to 0.5 milliampere, for Vx is equal to 0.9 voltage. Okay, so here they have asked to find out the VB. Let's go ahead and do that. Here we have a train's current equation, that's ID is equal to half mu n COX, that's 200 times 10 to the power of minus 6 times W over L, that's provided right here, 5 over 0.18 times VB minus V threshold, that is 0.4 whole square. And from this one we can solve for VB. Okay, we already have the train current provided, that is 0.5 milliampere, and if you plug it and solve for VB, you will get approximately 0.806 voltage. And that's the answer for the A part. Now let's look at the B part. B part is asking, now sketch Ix as a function of Vx as Vx goes from 0 to VDD. Okay, here we have three regions of operations. Okay, let's write this one. There are three regions of operations. Operation for Vx less than VB minus V threshold. M1 is in triode region, and at that time IDS2 absolute value will be greater than IDS1. This is for M1, this condition is in triode region. Now let's look at M2. For Vx minus VDD is greater than VB minus VDD minus V threshold 2. M2 is in triode. So IDS1 will be bigger than IDS2 magnitude absolute value. Okay, now for VB minus V threshold less than Vx and Vx minus VDD less than VB minus V threshold 2. Now M1 and M2 are in saturation. M1 and M2 are in saturation, and IDS1 is equal to absolute value of IDS2, that's equal to 0.5 milliampere at Vx is equal to 0.9 voltage. In all cases Ix is equal to IDS1 minus absolute value of IDS2. Now let's go ahead and draw the graph. So the graph will look like this. We draw the graph in terms of Ix and Vx. This is Vx and this one is Ix. The graph will look like this. And this is 0.9 voltage. And that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn electronics too, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.